So here we're talking about VLANs and trunking. You know, this whole concept of virtualization is relatively new. It's been around now for more than a decade and a half, but it's still relatively new to many. VLANs take a physical network, physical LAN, and split it up into many virtual LANs. So the literal description is it's a group of devices on one or more LANs that are configured to communicate as if they were attached to the same wire, when in fact they're located on a number of different LAN segments. Because VLANs are based on logical instead of physical connections, they are very flexible. So if I was to give you a diagram of this whole VLAN situation very briefly, it looks kind of like this. Right? In this particular instance, as you can see, we have this router here, and we have our fast Ethernet switches here, and these are on different floors, floors 1, 2, and 3. Let's expand this. And so this is on first 3 floors, and we've got accounting, marketing, and engineering VLANs that are devices on multiple floors. Okay? So the accounting VLAN in this particular simple instance comprises of machines that are on floors 1, 2, and 3, and same thing with the marketing, same thing with the engineering. It seems as if the servers are located on the top floor and the devices are on the floors below, but these VLANs treat this network as one logical network, even though these machines are placed on separate physical LAN segments, 3 physical LAN segments. So this is the virtualization aspect. Now, since they're logical and not physical, it makes them very, very flexible. Virtualization is not limited to LAN segments and VLANs. This concept also applies to servers and services that the servers provide. You can also have virtual routers. And I want to show you an example of a virtual machine, so you can see an example of a VM doing this. Here's a Linux virtual machine, a Red Hat Linux virtual machine that I have inside of my physical Windows box, and I'm just going to configure this really quick, and I'm going to assign a name. Now, this virtual machine right over here is inside of my physical Windows box, and this is actually a perfectly normal error, if you will, and it's restarting right now. So here I am. I'm going to log in as admin, and I am inside of this virtual box. All right. Now here's the thing. If I go over to machine, I go to settings. What I will notice is I have on the system, I have a processor attached to this. And I have 2 gigs of RAM allocated to this. I have storage allocated to this that is 8 gig in size. I have network allocated to this that is NATed at the moment, network address translation. And then I've got, display that is virtualized, serial ports and USB devices, all virtualized stuff. And I've got shared folders in here and so on if I need to have shared folders. So everything here is virtualized. Now here's the interesting part. Okay. Inside of this machine, it doesn't know that I am in a virtual environment. And it will behave as if I'm in a physical environment. Okay, so I'm just going to do that. Oops. There we go. Okay, so right now I'm going to bring the interface up. I'm going to bring the Ethernet interface up, and it is up. And I'm going to specify, this is the NATed IP address that this thing got, 10.02.15. And the IP address of my Windows machine that's on the outside, right here, is 192.168.127. Now the interesting thing here is if I do netstop Windows firewall, oops, I did not specify a admin connection. Right click, run as administrator, say yes. and I do net stop. Actually, what I'm going to do is I'm going to poke a hole in the firewall. I'm going to right-click over here, go to Open Network and Troubleshooting, go to Windows Firewall, allow program or feature to the application, change settings, apply file and printer sharing, check that box, click OK, and close this. Right from here, if I do ping 192.168.1.27, I'm able to ping this box. Not only that, because of the natting that I have done, I can ping Google, no problem, because it is going out using the connectivity of this box. It is natting that address. So if I go to machine and I go to settings and I go over to network and I change this NAT to internal network and I click OK. Right? Now, if I do ifconfig, the IP address is gone. If I do if I configure this and I say that I want to restart the network. Notice up here, the network has failed. I've got a virtual network adapter. If up ET80, look, it's trying to grab an IP address, and it can't. Now, the reason I'm showing you this is because this interface right over here, I have see the hardware address, 08002715A89B? Now, that MAC address does not apply to the MAC address of this machine. So if I go over here, let me exit out of here, and let me do ipconfig, all more. Take a look right there. There's a MAC address on this box. Notice the difference between that and this? That MAC address is provided by the virtualization by the hypervisor, or by Oracle VirtualBox, which is the virtual machine that has been given that MAC address and given that network by Oracle VirtualBox. Oracle VirtualBox is a hypervisor that sits on top of your Linux or Windows operating system. I'm trying to explain to you, virtualization comes in many different forms. Okay? So what I have done here, simply by sitting here and manipulating this, going over to network and changing that to a NAT, I'm able to make the network go outside. I can also make it bridged. Okay? I can make it a bridged adapter. I can make it host only. I can do whatever I like, and I can point it to this Realtek adapter right here. I can click OK. And if I do if up ET80, look, it says activation failed. Say device is not managed by, because I did a bridged network adapter, network restart, failed, OK. Okay. So here I am restarting, and it's trying to bring it up. If I do ifconfig, notice the MAC address. See it? 192.168.1.74. Now that MAC address is unique. Since I made it a bridged adapter, it goes, oh, you want me to communicate, you want me to use the physical adapter that is on this machine, which is this network adapter right here, the Realtek PCI Gigabit family adapter, and you want me to assign multiple IP addresses to that NIC using my own hypervisor. So the MAC address didn't change, the IP address did, and I can also make this IP address static. So inside of the Linux OS, if I go, and I'm not really going to talk to you about how to do this in Linux, because that's not my focus. My focus is to explain to you virtualization coming in many different forms. So I'm going to go over to sysconfig, and I'm going to go over to network scripts, and I'm going to go over to nano fcfg t80, and I'm going to make this, I'm going to make this IP ADDR 192.168.1.220. Net mask is 255.255.255.0, and I can do service network restart, okay, and I do ifconfig, and I do if up ET80, and I do ifconfig, and there's my static address, 192.168.1.220. So I can assign, as you can see, my own IP address to this box. Not just that, if I ping 192.168 1.27, which is my Windows machine, since it's on the same subnet, I'm able to address it no problem, right? Follows the same exact set of rules. But inside of this, I'm able to talk and communicate with this box as if it was a physical machine. Now, if I try to ping Google, I can't, okay? The reason for that is because I have not assigned if I go over to etc and I go to cat resolve conf, I don't have a name server defined here. Okay, so I'm going to do nano resolve conf, and I'm going to do name server 88888 and oops and come on 8, and I'm going to do inside of my sysconfig network scripts, and I'm going to do vi if cfg80, and I'm going to specify that the gateway equals 192.168 1.254. Oops. And if I do a ping, okay. Now it still doesn't know what Google is, right? So if I need to do a service network restart, and if I do if up et80, let that reset, and if I do if config, I'm able to readjust things. Okay. Now the interesting thing here is if I do 168.1.254, there it is trying to ping my gateway and it can't. I think I don't have it going out. Yeah, I don't have it going out. But the interesting thing here is that you have to remember that this is in a virtual universe. Let me bring up the network control panel in this machine. Here's my VirtualBox network adapter, if you will. When I installed VirtualBox, Oracle VirtualBox, it brought up a hypervisor. And it created a way for me to install multiple VMs inside of the single physical box and share the processor, RAM, disk, network, display, keyboard, mouse, and all of the other resources. So VLANs allow me to do that. Inside of the network universe, I'm able to take advantage of the virtualization concepts. Here's 3 physical networks, right? And then I've got 3 more logical networks because I have split them up, right? What would I have to do if I didn't have VLANs available? Well, in order for me to implement this structure, let's say that these are servers, for the accounting, marketing, and engineering department. If these are servers and I wanted the servers to be on the same floor as the individual computers, I would have to, what? Wire this up here physically? Yuck, right? And then wire this up here physically? Yuck. And what if I move these servers around? What if I move this? What if I move this, for example, from here to down here, or down here, or over here, or over there, right? With a VLAN, it really doesn't make any difference. It gives me a lot of flexibility, right? It gives me tremendous amount of flexibility because I'm able to move. Not only I have a VLAN, I'm able to move these around anywhere I like, as long as I put this device on the same VLAN as what I need it to be in. I can move it anywhere I like. And this is a logical diagram, as you might imagine. Okay, this is the physical stuff and the virtual stuff. Physical stuff, in this case, horizontal. Virtual stuff, in this case, vertical. Not always the case. So what I want to do is, I want to explain to you a couple of other things. So here's trunking. Now, Cisco switches have the ability to trunk. You can use ISL, which I'll explain in a minute, or IEEE 802.1q. Now, trunks carry traffic from all VLANs to and from the switch by default, okay? But can be configured to carry only specific VLAN traffic if needed. Okay? Certain types of switches can negotiate trunk links. Okay? 2 mechanisms, ISL and IEEE 802.1q. ISL is inter-switch link, which is a Cisco proprietary protocol. IEEE's 802.1q is IEEE's recommendation for VLAN tagging. This maintains ISL. It maintains VLAN information as traffic flows between switches and routers. Okay, this is Cisco proprietary, right? Dynamic trunking protocol, or DTP. Now, if a port can become a trunk, it may also have the ability to trunk automatically, and in some cases, even negotiate what type of trunking to use on the port. The dynamic trunking protocol, or DTP, provides the ability to negotiate the trunking method with the other device. Okay? Trunking method. Okay. ISL, IEEE 802.1q. So what I want to do here is I want to show you, in my particular instance, what I'm going to be showing you. I'm going to be configuring. I'm going to configure VLANs. Oops. I'm going to be configuring VLANs and trunks on these two switches. Take a look at this. I've got Ethernet 1.1 right over here, and I've got Ethernet 1.2 right over here. Let me change this color. Okay. So Ethernet 1.2 over here, 1.1 over here. I've got switch 1 and switch 2, and I've got 4 PCs, if you will, and each of these PCs may be providing, well, resources or services, different types of services, and maybe these are servers. Maybe these aren't even PCs. Okay. And furthermore, if you were to take a look, in my case, I have got, look at these VLANs that I have here. The VLANs that I have, I've got VLAN 20 over here. I've got VLAN 1 in these 3 machines. And I've got VLAN 20 over here. So that means that this is the one that is not the one that is in pink or peach, is the one that is all isolated by itself, or PC4. So I want to virtually, if you will, isolate this, and I want to virtually put the 3 of these in the same place. Here are the IP addresses. Notice something. Here, right here, this is done a lot. This right here, the 192.168.1, the third octet, describes, for example, by looking at the IP address, what VLAN it belongs to, and here is .20, which is that VLAN right there. Okay. So I've got the interfaces. Ethernet 00 in this particular case is what these addresses are assigned to, and these devices, the 2 of the devices are on switch 1, which is PC1 and PC2, okay, and the 1 device is on switch 2. Okay, I'm sorry, this is on switch 2. So I want these 3 to behave as though they are on the same network, and this to behave as if it's on a different network. Even though they are on different physical LANs, I want these to behave as though they are on the same LAN. They're numbered 100, 101, and 110. Right? So I'm going to describe this, and I'm going to show you how this is done.